to lunch now. So the next speaker we have is Rob Burgess from Inosys. Rob has spent time working in the offshore energy industry with a focus on GIS. He specialises in Postgres and PostGIS, and we're going to hear about vessel monitoring, I think. Cool, thank you.
Is that working?
Yes.
Yeah. Go to the back. Right, nice, cool, thanks. Yeah, so today I'm going to be talking about how we use real-time vessel monitoring with some open source tools like Postgres, PostGIS, and Python for some geospatial analysis, visualization. I'll be showing you how we've applied these technologies to monitor some vessel movements around some offshore energy facilities and how we can actually gain insights from the data that we collect. Use the clicker. Cool. So as I mentioned, this is focused on an offshore energy project. It's about 25 kilometres off the coast of Equatorial Guinea. Occupies about 450 square kilometres. There's a mix of different platforms, different structures there, including things like platforms, FPSOs, subsea wells, all linked together by things like pipelines, umbilicals, that kind of thing. So an FPSO stands for floating production storage and offloading. These are really large vessels used in oil and gas operations to extract oil and gas from underwater wells, where it's then processed, stored, and offloaded to tankers. And that's what this diagram is showing here. So you have these underwater wells, it's out on the seabed, the oil and gas goes up into the FPSO, where it's then processed, stored, and then offloaded by these boys here. You can also have drilling platforms in the region, and they can tie into the FPSOs. So the FPSO sort of forms the centre of the field I'm talking about today. This is what it actually looks like. So we have our subsea wells that sat on the seabed here. These are linked into this FPSO, and then this is our offloading buoy here. So tanks would come up, park next to that, fill up, and then head back into shore. Then we also have some platforms that are nearer to shore, and these two are linked into the FPSOs. So there's lots of different structures, lots of facilities in the region, and there's lots of vessel traffic that comes into and out of the zone, sort of maintaining different parts of the field. And that's where the role of mooring master comes in really useful. So these guys, they play a key role in monitoring several aspects such as the approach of vessels to the region. They monitor the proximity of vessels to platforms and FPSOs. They might want to answer questions like, has a vessel strayed into a restricted zone? Has a vessel spent too much time in a zone if it wasn't out there? Has a vessel safely returned to port? And yeah, is a vessel stationary or in transit? So these questions or aspects are really difficult to keep an eye on if you don't have access to real-time vessel tracking data. It's just much harder to manage with like risks and safety aspects. So that's where AIS comes in. So AIS stands for Automatic Identification System. This is a maritime communication system used to report a vessel's position, speed, heading, amongst other things, which is then picked up by stations that are either onshore on platforms or on satellites. And yeah, you can subscribe to providers of this data. Probably the most famous of these is marine traffic. Spire is another one, focusing more on like satellite data. And you can also have access to the platform systems too. So yeah, we managed to get access to all three of these systems, and that gave us like really good coverage of the field that I showed you earlier. And yeah, that then allowed us to actually track the vessels, identify vessels coming into and out the area to track. So there were quite a lot of those vessels. Obviously, I'm not going to go through all of those. There are a lot of them. So just to give you an idea of what type of vessels I'm talking about. So we have things like the red snapper. So this is like an offshore supply vessel, bringing stuff to and from platforms. We have the red fox. So this is a tug that helps to maneuver larger vessels into position, like tankers and things. And then we have the CM day. So this is the vessel that specialises more in underwater inspections and like underwater installations, maintenance, that kind of thing. So just to give you an idea of the different types of vessels that come to that region. Cool. So we've got our AIS data, we've got our vessels being tracked. So the next stage is basically to create zones around different parts of the field to keep track of where these boats are going. So this is basically the creation of geofences. So I created these in QGIS, and uploaded them to PostGIS. Effectively, the first one is just the regional kind of geofence. So this would track any vessel coming into and out of the whole area, and any vessel going into this is tagged as being in field. We also have some more kind of project-specific ones. So we have some around platforms, some around platform loading and unloading areas. So this is where a vessel would park next to the platform, and there would like wind stuff off and on the back deck. And then also some subsea well clusters too. So yeah, vessels going within these are tagged as being within a project geofence. Also have some dynamic geofences. So these are applied to the FPSOs. So FPSOs, although they are actually anchored in place, they do actually move a little bit depending on where the weather is coming from. So in these situations, you can use a function like this in PostGIS, which takes every new position, comes in, extracts the geometry, and then just uses this nesting buffer command here to just recreate that buffer and center it nicely around that new position. And finally, we have some port geofences. So these are obviously keeping track of, like, is the vessel, so the vessel right back at port, or has it just there at port? Cool. So I appreciate I've just been through a load of stuff there. So just to very quickly recap, we have sourced our AS data, we've tracked our vessels, and we've created our geofences. And now that we've done this, now that we have this set up, we can create a workflow that can process every new incoming position and sort of classify vessels state. So that's what I'm going to go through now. It starts with Postgres' list and notify feature. This is a really useful feature in Postgres that will take every new position that comes in, and then we can use a function like this to extract things like the timestamp, the geometry, the speed, log them into these variables here, and then it builds this like JSON object, which would look something like this in the bottom right hand side, and then it would switch from this kind of listen mode to the notify mode, and it would broadcast that message on the channel, which in this case is this channel, this channel here. And that can be picked up by an external application, which in this case is a Python script. So that Python script is hooking into the database and listening in on that channel that we just created earlier. So any message that comes in, it would then process that message, process the payload, extract all the attributes from that message. So things like grabbing the vessel name, the element sign, timestamp, geometry, speed, etc., etc. And then it will go ahead and process that data. The kind of first stage of that is identifying whether there are actually any intersections with the geofences that we just created a couple of slides ago. So I appreciate I'm just showing some blocks of code here. I've got a bit more of a visual explainer in the next slide. If I just quickly go through this, so effectively we grab our geofences that we created, our PostGIS. We set up or initialize some variables that will help us to keep track of whether a vessel is within a geofence or not. And then we're effectively looping through the geofences, loading the geometry and testing whether these vessel positions are contained within any of those geofences. Cool. So just to do a bit more of a visual explainer. So say our vessel is where this red, so it's where this black X is. Technically, it's going to be within both this geofence and this much larger geofence. That would create a data structure that would look something like this. So you can see there's two parts to that there. We have that area column, which shows you how large each of those geofences is. And then we're then actually sorting that data structure by the area, and we're selecting the smallest one. The reason we're doing that is because, generally speaking, the smaller the area represents like the more kind of critical, the more kind of critical zones, like a mooring area or a subsea well cluster, something like that. So that's the reason why we're doing that. Pretty sure I'm just running out of time. So this is a flow diagram just to show you how we're actually determining the vessel state. So for example, if we start where it says vessel intersection, if our vessel is in a project geofence, obviously we're within the project area. If we're within a port geofence, obviously we're within the port. If we're within this field in-field geofence, and its speed is greater than what you can use to do knots, where it transit. If it's less than 2 knots per stationary, and if there are no intersections and we're not within a geofence, our speed is greater than 2 knots. We're transiting if it's less than 2 knots per station. Cool. And then we can upload the vessel state to the database. And this is an example of what the table would look like. So we have an MMSI on the left-hand side. We have the timestamp showing the time at which a vessel entered the particular state. And then we have the geofence ID here. On the right-hand side, this is the state that's been reported for each of the vessels. So, like, is it a project geofence? Is it stationary? Is it out of range? Is it in transit? That kind of thing. This might do a very risky line demo. I actually loaded it earlier to avoid that. So yeah, this is pretty simple, to be honest. I've just done these few visualizations in Python and just create this really simple dashboard. We don't actually use this with a web map for various reasons, mostly due to like sensitivities and stuff. But yeah, just to give you an idea of what's possible. So essentially, you just like pick a vessel if you're tracking, select your date range, and then like spits out all these, just like this table showing like a state percentage breakdown of each of the vessel states. You've got this horizontal bar graph here, so each of the coloured blobs there represents time spent in each one of those vessel states. The second chart is kind of similar to that. It's got like it's just a stat bar chart off the one above. And then finally we have a bit more of a detailed look at that. So like, say you're interested in knowing like which geofences the vessel was in, you can hover over and see like for the time period you've selected. It tells you like it was in this Noble Venture FPSO geofence. So yeah, you can do this for multiple vessels or whatever time period you're interested in. Obviously, I talked about AIS data. You can also do this for ADSB, for aircraft data too. So this one, for example, this is like a helicopter which would be ferrying crew. Oops, maybe that's the right day range. Ferrying crew to and from platforms. So you can see it spends most of its time like actually sat in an airport, but these red blobs represent time it's actually flown people to and from the platforms. So it's went to event mode. Sorry, guys. Yeah, cool. So just to go through some conclusions, yeah, hopefully I've shown you how we can use AIS data in combination with some open source tools to track vessels around some offshore energy facilities. We've sourced our AIS data from multiple sources. We've identified vessels we want to track, and we've created some geofences. And yeah, then we created a workflow to process those incoming positions. So we use PostgreSQL as a notify feature, processed the incoming positions, identified some geofence intersections, determined the vessel states, and then we uploaded that to a database. And then finally, we visualized that data using some charting to dashboards. So yeah, I don't know how much time I have left, probably not much, but I have finished. So yeah, thanks very much. Cheers. Cheers, guys. Second.
Thank you very much for that. That was really fascinating. Are there any questions? Lots of questions. Okay.
So have you managed to find any like instances of AIS spoofing going on with this? Like anything that suddenly appeared where it shouldn't?
So this is focused like on the sort of west coast of Africa. So there's probably less in this particular region. There's less of that going on. But yeah, I see where you're coming from. Like if it's like in the Gulf of whatever that's called, sort of in the Middle Eastern region, there's probably a bit more of that potentially going on, and you might have stuff popping up or vessels appearing where they actually aren't. You see what I mean? But yeah, there's not much you can really do about that in the sense that you're just fed the data that you subscribe to. So yeah, I guess you just have to know that this vessel is there or not there potentially.
Yeah, so is what you're building, is it for like auditing purposes, or is it so they can actually react and say, okay, we've just seen a vessel go where it should?
Yeah, basically. So these mooring masters, they have so many vessels that they need to keep track of. So yeah, they need to monitor like yeah, has this vessel docked with this platform, have these crew got off, have these supplies been loaded, has the vessel got back to shore okay, that kind of thing. So yeah, hope that makes sense.
Hello. So the geofencing can be implemented on berth level activity?
On boat level.
Berth level. For inside a port, you have a berths.
Oh, yeah. So you can create like whichever sort of sized geofences you would be interested in doing. Yeah. So it's very customizable. It's very flexible. So we create all kinds of like random geofences. So yeah, you could do that.
All right. Thanks.
Hi, thanks for that. It looked like you were doing most of the actual geospatial operations in Python once you'd got the geometries from the Postgres database. Had you considered doing the actual sort of intersections and so on in Postgres using the PostGIS operators? And was there a reason you didn't go down that path?
Yeah, it's funny actually. I actually worked on this for ages, and I showed it to our senior developer. And the first thing he said was, "Why did you do it? Why did you do it in Python?" But it's actually been really useful for me actually to sort of develop my Python kind of skills and things. So yeah, I hear what you're saying. Like you could do a lot of the those kind of geospatial type functions actually within Postgres. So although it is, I guess, if you have like more kind of I don't know, specific or detailed needs, Python's probably a bit more usable, a bit more kind of extensible. You can,
I can see
define,
the
like,
trade-offs. There's a trade-off definitely between them because you can get the flexibility in the Python, and you might end up with monster SQL queries, which in Postgres that I find quite difficult to parse. But yeah, thank you.
Brilliant. No, sorry, no time. Get back on your seat. Brilliant. Thank you very much for that. That's great.